Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about spectroscopy. It is the branch of science that deals with the study of interaction of matter with light. Here important point, you should note it, that interaction of matter with light. In another form, or in another way, you can define spectroscopy is like that. It is the branch of science that deals with the study of interaction of electromagnetic radiation with matter. So, what is electromagnetic radiation? Electromagnetic radiation consists of discrete packages of energy, which are called as photons. A photon consists of an oscillating electric field and an oscillating magnetic field, which are perpendicular to each other. So, you can see in this picture, magnetic field and electric field are perpendicular to each other. And you can also see the source and their directions. Now, electromagnetic radiations have two important parameters, frequency and wavelength. What is frequency? It is defined as the number of times electrical field radiation oscillate in 1 second. The unit for frequency is hertz. 1 hertz is equal to 1 cycle per second. Wavelength, lambda, it is the distance between two nearest parts of the wave in the same phase. That is distance between two nearest crest or trough. You can see in this picture the wavelength and amplitudes. The relationship between wavelength and frequency can be written as C is equal to frequency into wavelength. You know, as photon is subjected to energy, so E is equal to h nu, and which is equal to Sc by lambda. Now, electromagnetic radiations, you know, the gamma rays, X-rays, UV, visible, IR, microwave and radio wave. Their wavelength, another scale is frequency, another scale is energy. So frequency and energy in one directions and wavelength is another directions. So you can see here white light when a strike on prism, it gives red, orange, yellow, green, blue, indigo, violet, and also you can see here dispersion angle, and that angle is important here. So you also know the violet, indigo, blue, green, and their range in wavelength, and the unit is nanometer. Now, principle of spectroscopy. The principles of spectroscopy is based on the measurement of a spectrum of sample containing atoms or molecules. A spectrum is a graph of intensity of absorbed or emitted radiation by sample versus frequency or wavelength. You also know the spectrometer is an instrument designed to measure the spectrum of a compound. What is the principle of spectroscopy? The first, absorption spectroscopy, an analytical technique which concerned with the measurement of absorptions of electromagnetic radiation. UV, visibles spectroscopy, IR spectroscopy. Now, emission spectroscopy is also an analytical technique in which emission of a particles or radiation is dispersed according to some property of the emission, and the amount of dispersion is measured. For example, mass spectroscopy. You know the EMR, electromagnetic radiation short form, the interaction of EMR with matter. So interaction of EMR with matter, electronic energy level. At room temperature, the molecules are in the lowest energy level, E naught. When the molecules absorb UV visible light from EMR, one of the outermost bond, lone pair electron, is promoted to the higher energy states such as E1, E2, En. It is called as electronic transition, and the difference is as del E is equal to H nu is equal to En minus E naught, where N is equal to 1, 2, 3 it is. Now vibrational energy levels. These are less energy level than electronic energy level. The spacing between energy levels are relatively small, that is 0.1 to 10 kilocalorie per mole. Examples: when higher radiation is absorbed, molecules are excited from one vibration level to the another. It vibrates with higher amplitude. The third important point, rotational energy level. These energy levels are quantized and discrete. The spacing between energy levels are even smaller than vibration energy level. If you look at this, then you can see del E electronics is much greater than del E vibrational and then del E rotational. Now Lambert's law. What is the Lambert's law? When a monochromatic radiation is passed through a solution, the decrease in the intensity of radiation with thickness of the solution is directly proportional to the intensity of the incident light. Let I be the intensity of incident radiation, X be the thickness of the solution, then minus di by dx directly proportional to I. So minus di by dx is equal to ki. On integration, the equation between limits I is equal to I naught and x is equal to 0, then I is equal to I at x is equal to 1. So we get ln I by I naught is equal to ki. So 2.303 log I by I naught is equal to ki. Log I by I naught is equal to minus k 2.303 L, where log I naught by I is equal to A. A is absorbance, here L is the length of your cuvette. So K divided by 2.303 is equal to E, which is absorption coefficient, and A is equal to En. Now Bayer's law. What is Bayer's law? When a monochromatic radiation is passed through a solution, the decrease in the intensity of radiation with thickness of the solution is directly proportional to the intensity of incident light as well as concentration of the solution. Let I be the intensity of incident radiation, X be the thickness of the solution, and C be the concentration of the solution. Then minus di by dx is equal to Ci. So minus di by dx is equal to Kci. Integrate equation between limit I is equal to I naught and at x is equal to 0. Then I is equal to I at x is equal to 1. We get ln I by I naught KCl. So 2.303 log I naught by I is equal to KCl. Log I naught by I is equal to K divided by 2.303 Cl, where log I naught by I is equal to A, absorbance. K divided by 2.303 is equal to E, molar extension coefficient. So A is equal to ECl, which is Bayer's law. So A is equal to ECl and T is equal to I by naught, or minus log T is equal to log I by I naught is equal to A. So from the equation it is seen that the absorbance, which is also called as optical density OD of a solution in a container of fixed path length, is directly proportional to the concentration of a solution. So my friends, I hope this video will helpful to you. If you like this video, then subscribe my channel, and thanks for watching.